Good morning students. Welcome to the last session of the conducting polymers where we are going to discuss the properties, synthesis of certain conducting polymers, especially polyaniline, which is used widely in the industries. Now let us go to the session. Conducting polymers, we are going to discuss about polyaniline, polypyrrole and polyacrylonitrile. So polyaniline is PANI. We call commonly as PANI. So this is a conducting polymer which can be synthesized. Conducting polymer, they are semi-flexible rod polymer family and they can be synthesized as bulk, powder, cast films or fibers. Also, one of the oldest known conducting polymer. They are first discovered in 19th century and it is also known as aniline black. Synthesis of polyaniline, it is a very simple synthesis. We can easily take 0.1 molar aniline and aqueous sulfuric acid, total volume 200 ml, and what you are going to do is you just stir it just by stirring. Then you add K2Cr2O7 potassium dichromate drop by drop during stirring. What happens? You have a final product which is filtered, washed, and washing should be done with dilute sulfuric acid only, not with water. You have to wash it with dilute sulfuric acid and you have to dry it at 60 degrees centigrade and in vacuum. Dry it in vacuum for 12 hours, which will result in your emeraldine salt. Which will result in an emeraldine salt, which is polyaniline. Simply, I can write the reaction like this. I am taking aniline. As a chemist, we should be able to write a reaction. So, this is aniline with one amine group and K2Cr2O7 oxidizing agent. In the presence of dilute sulfuric acid, I get a polymer like this, which is PANI, NH. Again, I am writing the structure. A ring, NH, and so on, n times. The polymer chain will be repeated n times. Okay, I am giving here, here, and then here. Fine. So this is nothing but polyaniline, PANI. I am calling this as PANI. And what happens now? The importance of this is. The structure, 3 types of polyaniline is possible. One is, it is found in 3 oxidation state. The first oxidation state is leucoemeraldine. The second oxidation state is simply emeraldine. And the third oxidation state is perniger aniline. These are the 3 oxidation states of aniline, where the structures can also be seen. You can refer some good websites for that, the structures. The only difference is the bonds that is present between this. In one form, only nitrogen is present where you have double bonds. In the other form, there is present of NH, and this form is leucoemeraldine structure. So, the structure that we have drawn here is leucoemeraldine. The other 2 structures, it will be having only nitrogen. Okay, this part particularly is used in polynanowires. This finds applications in poly nanowires, particularly one-dimensional polyaniline nanowire, which is an electrically conducted polymer, and it can be used as active layers for sensor applications whose conductivity range can be used to change to detect chemical and biological species. Why polyaniline is? Why do we need polyaniline? One, it is highly sensitive. Second, it is very simple in detection. Third, it is rapid, flexible, and then easy to synthesis. For all these reasons, we use polyaniline. And this polyaniline, normally not only polyaniline, all the conducting polymers, they have many applications. The first application is anti-static in photographic films. Anti-static substances in photographic films and corrosion inhibitors. They are used as corrosion inhibitors, compact capacitors. Also, they can be used in anti-static coating. They can be used in smart windows, for coating of smart windows, electrostatic coating of smart windows. Also, a second generation of conducting polymers have been used for industrial uses like transistors, LEDs, etc. Even in solar cells, we are using it. Conducting polymers are used even in the solar cells. Next, coming to polypyrrole. Let us see only the properties of polypyrrole. The polypyrrole structure is, it is a 5-membered ring polymer where you have NH group, and also it is aromatic in nature. You have N molecules of polypyrrole here. The conductivity is 7.5 into 10 power 3 cm-1, and the type of doping that is prepared is P doping. And if you see the property, this also has high conductivity, very good conductivity, and it is easy to prepare through surface modification. But it is rigid, brittle, and it is insoluble in most of the organic solvents. So, this is one of the important property of polypyrrole. What is polymer modification? What do I mean by surface modification? Surface modification is done just by blending to improve the properties of the polymer through blending, grafting, or even through curing. We can do surface modification of a polymer. Blending is the physical mixture of two or more polymer to obtain requisite properties, and here you have grafting, where it is a method wherein monomers are covalently bonded to the polymer chain, and in curing, the polymerization, the mixture forms a coating which adheres to the substrate by means of physical forces. Now I can give you the diagram for these. Let us take blending through explained through diagram. Now if I take polymer A, let us take this is polymer A and this one is polymer B. Through blending, you get a combination like this. This is nothing but blending of a polymer. This is the first one. Second is grafting. So, grafting can be done. This is your polymer chain, a monomer, your polymer and your monomer, grafted like this. So this is done between a polymer and a monomer, grafting. The third and final one is curing. So how do you do curing? Again you take a polymer chain. This is your polymer and your monomer. As I have told you, there is a surface coating and you have the layer of monomer like this. So this is your layer of monomer and this is your polymer. This is nothing but curing. So if you see polypyrrole, you have this as this structure. It is a 5-membered ring. Polypyrrole is a 5-membered ring and it has a conductivity, very high conductivity. It can be prepared by surface modifications, by blending, curing or grafting like this. I have given you the structures how to do blending, curing and grafting. They are rigid, brittle and insoluble in nature. And I have also given the applications of conducting polymers. Thank you for this session.